Hi everyone, welcome to the second part of the series 1000 must solve problems for NEET physics. Question number 11. An electron starting from rest has a velocity that increases linearly with time, that is v is equal to kt, where k is equal to 2 meter per second square. Then the distance covered in the first 3 seconds. First 3 seconds means t is equal to 0. T is equal to 0 to t is equal to 3. What is the distance traveled? We have to calculate. Okay. So we know that distance is equal to integration of velocity with respect to time. Here the limits are 0 and 3. So what is velocity? V equal to kt given. So kt, integration of kt with respect to t between the limits 0 and 3. So k is a constant. You can take this outside. Integration of t is t square by 2. So what happens? K into t square by 2 between the limits 0 and 3. Now, what is the value of k? K is equal to 2 meter per second square. So 2 into 3 square by 2. Okay, minus 0. Since the lower limit is 0, minus 0. 2 and 2 gets cancelled. So x will be equal to 3 square. 3 square means 9 meters. So therefore, first option is the correct one. We'll go to the next question. A body is released from the top of a tower of height h meter. After 2 seconds, it is stopped and then instantaneously released. Means you haven't wasted time. Instantaneously it is released. What will be its height after next 2 seconds? Okay. Now there is a tower. Okay, there is a tower. Height of the tower is h. Then a ball is released means initial velocity is 0. Initial velocity is 0. So we'll use the equation x is equal to ut plus half at square. Ut plus half at square. So since the ball is coming down, the distance traveled, x is negative, u is 0. So this term ut becomes equal to 0. Minus x equal to minus 5 t square. Means a is minus 10. Minus 10 by 2 is minus 5. So we will get x is equal to 5t square. Okay. After 2 seconds, where will be the ball? X will be equal to 5 into 2 square. 2 square is 4. 4 into 5 is 20. Okay. Distance traveled will be 20 meter. In first 2 seconds, it travels a distance 20 meter downwards. Now what happened? This has been stopped. The ball is stopped now. Means again you made the initial velocity 0. Then instantaneously released. Means you did not waste the time. What will be its height after next 2 seconds? Okay. In the next 2 seconds, again this ball will travel a distance equal to 20 meter. Now, what will be the height? Height will be measured from the ground. So what is this distance? This distance is equal to, okay, h minus 20 plus 20, 40. Correct now? So this distance is 40. So this will be h minus 40. So fourth option is correct one. Now we will go to question number 13. A particle starts with velocity u and moves with constant acceleration a. Constant acceleration a. What is the nature of graph between time and displacement? Okay. What is the relation between displacement in time, displacement and time when the acceleration is constant? That is x is equal to ut plus half a t square. Now this is in the form of y is equal to ax plus bx square. Y is equal to ax plus bx square is an equation of asymmetric parabola. What do you mean by asymmetric? The word asymmetric. Say for example, so this is one equation of parabola. Y is equal to bx square. How does the graph look like? Graph looks like this. What does it mean? This parabola is symmetric about y-axis. That is why this is the equation of symmetric parabola. Now, in projectile motion, you might have studied nature of trajectory of a projectile. So which equation you will get? You will get an equation something like y is equal to tan theta into x minus gx square divided by 2u square cos square theta. If you remember, this formula is in the form of y is equal to ax minus bx square. Okay, now this is the graph. Now if you see in this graph, this parabola is not symmetric about y-axis. That is why y is equal to ax minus bx square is an equation of asymmetric parabola. Next we will go to question number 14. A simple pendulum hangs from the roof of train. The string is inclined towards the rear of the train. See, there is a train with us. So this is front end of the train, this is rear end of the train. The string is inclined towards the rear of the train. So there is a simple pendulum. Simple pendulum is inclined towards the rear end of the train. Means definitely what should be happening? If the train is accelerating in this direction, okay, then definitely the simple pendulum moves backward. That is, it will get inclined towards the rear end of the train. So therefore definitely the train is under accelerated motion. Question number 15. A car accelerates from rest at constant rate of 2 meter per second square for some time. Then it retards at a constant rate of 4 meter per second square and comes to rest. So what is the maximum speed attained by the car if it remains in motion for 3 seconds? To calculate maximum speed, I should use the formula V is equal to alpha beta divided by alpha plus beta into t. So what is alpha? Alpha means acceleration. This is alpha. This is beta. So it will be 2 into 4 divided by 2 plus 4. 2 plus 4 is 6 into time taken is 3 seconds. 3 goes twice. 2 gets cancelled. So the maximum speed is equal to 4 meter per second. So third option is the correct one. For the derivation of this formula, please refer the synopsis part, link for which will be given in the description. Question number 16. A car accelerates from rest at constant rate of 2 meter per second square for some time. Then it retards at constant rate of 4 meter per second square and comes to rest. If the total time of which it remains in motion is 3 seconds, what is the total distance traveled? To calculate total distance traveled, we have to use the equation x is equal to alpha beta divided by alpha plus beta into t square. I missed half here. X is equal to half into alpha beta divided by alpha plus beta into t square. Now this equation comes from the equation x is equal to ut plus half a t square. If you remember, here since the car starts from rest, this u becomes 0, this term becomes 0. In the place of a, I am writing the equation of effective acceleration. Effective acceleration is alpha beta divided by alpha plus beta into t square. So that is equal to half into alpha beta 2 into 4 divided by 2 plus 4 is 6 into t square. So t square means 3 square. So 2 goes 3 times. This 3 and this 3 gets cancelled. 4 into 3 will be 12. 12 by 2 is 6. So therefore distance travelled will be equal to 6 meters. Fourth option. Now we will go to question number 17. A ball dropped from a height h reaches the ground in time t. What is the height at t by 2? Okay. So you have dropped a ball. Okay. It from a height h and it reaches the ground in time t. Okay, so in time t by 2, what will be the height of the ball? Okay, so we know the equation h is equal to half gt square. When the ball is dropped, h is equal to half gt square since the initial velocity is 0. Or I can write h is proportional to t square, or we can write h prime by h is equal to t prime by t whole square, or it will be t by 2. T prime means so t by 2 by t whole square. So t gets cancelled. 1 by 2 whole square will be 1 by 4. So therefore h prime will be equal to h by 4. Okay, what does it mean? Distance traveled by the ball in a time equal to t by 2 is h by 4. Okay, distance traveled by the ball is h by 4. Therefore, what is the height? Now, what is the height? Height is always measured from the ground. So, this height now is equal to original height h minus h by 4. See, from here to here, the distance is h. Now, the ball has traveled a distance h by 4. Now, therefore, what is this distance? This distance is h minus h by 4 will be equal to 3h by 4. So, ball is at a height 3h by 4. Fourth option is the correct one. We will go to question number 18. The distance time graph of a particle at time t makes an angle 45 degree with time axis. After 1 second, it makes an angle 60 degree with time axis. What is the acceleration of the particle? So, to find acceleration, what is acceleration? Acceleration equal to final velocity minus initial velocity divided by time taken. Since they are speaking about distance time graph, okay, in xt graph, we should see what is slope of xt graph. Slope of xt graph is velocity. Slope of xt graph is velocity, or slope is equal to y by x. So, what is this? This is delta x. Okay, this is delta t. This is delta x and this is delta t. Slope equal to delta x by delta t. Okay, if you consider this angle as theta, this angle also will be equal to theta. So this can also be written as tan theta. Correct now? What is tan theta? Tan theta is opposite side divided by adjacent side. So tan theta also gives you velocity. So therefore, acceleration equal to final velocity means what is final tan theta? Final tan theta is tan 60, final angle is tan 60, minus initial velocity is the tangent of 45 degree minus tan 45 degree divided by time taken. What is time taken? After 1 second. So time taken is 1. So acceleration equal to tan 60 is root 3 minus tan 45 is 1. So acceleration is root 3 minus 1 meter per second square. Next, we'll go to question number 19. The displacement time graph for the two particles A and B are straight lines inclined at angles 30 degree and 60 degree respectively. The ratio of velocity is VA and VB will be. So we know that since tangent of the angle made by the displacement time graph gives you the velocity, VA by VB will be equal to tan 30 degree. Okay, for particle A, okay, that straight line is inclined at angle 30 degree, fine. Tan 30 degree divided by tan 60 degree. What is tan 30? Tan 30 is 1 by root 3 divided by tan 60 is root 3. So it will be 1 by root 3 into root 3 will be 1 by 3. 1 by 3. So it is fourth option. Question number 20. A car can be stopped over a distance x when its momentum is p. What will be the stopping distance when the momentum is 2p? Okay, when the momentum is p, let us suppose that the velocity is v. When the momentum is doubled, when the momentum becomes 2p, mass will not change. What may happen is the velocity gets doubled. So now we have to see the formula of stopping distance. Stopping distance is equal to u square divided by 2a. Stopping distance is directly proportional to square of the initial speed. So new stopping distance is equal to, say initially the velocity is v. Initially the velocity is v. Now the velocity has become 2v. So 2v whole square divided by 2a, or that will be equal to 4 into v square by 2a. 4 into v square by 2a. But what is v square by 2a? Original stopping distance. Correct now? Original stopping distance. So ds prime is equal to 4 into, what was the original stopping distance? Initially when the velocity is v, the stopping distance was x. So 4 into x. So new stopping distance will be equal to 4x. Therefore third option is the correct one. Thank you very much. Please subscribe the channel so that I'll upload all the 100 videos consisting of 10 problems each for your NEET preparation. Thank you very much.